Hello and welcome to the Daily Space for today, November 29th, 2018. My name is Dr. Pamela Gay and I am your host, and I am here to put science in your brain. Today we're going to cover a number of the top stories from astronomy and space science. As always, this program is brought to you by the Planetary Science Institute, working in collaboration with Youngstown State University. In today's top story, we have a tale of many globular clusters. This set of galaxies that we're looking at make up the Coma cluster. This is a system of thousands of galaxies that are gravitationally bound together, orbiting one another in rapid fire and undergoing many different gravitational interactions. As they go through this orbital dance, these gravitational interactions can strip stars, dust, gas, and even globular clusters out of this myriad of galaxies. New images taken by the Hubble Space Telescope have zoomed in, or at least deep dived in, measuring photon after photon until they could see the faintest things in this cluster of galaxies. In this case, what they were able to find, circled here in a faint background of small teal circles, is thousands of globular clusters. So far, they have been able to identify 22,426 globular clusters occupying the spaces between the galaxies in the Coma cluster. As I said, these globular clusters are generally stripped out of their originating galaxies through interactions. Now, today, all these different systems are tracing out where are the high gravity regions in which they will fall in, and what are the lower gravity regions where they tend to get pulled out. By observing long enough to see all these myriad all this myriad globular clusters, astronomers can now trace out the field map of gravity within the Coma cluster. A good way to think of this is, as children, many of us had these magnetic field toys where we maneuvered a magnet around, we shook it, and then iron filings traced out where the magnetic field was in this two-dimensional toy. Well, in this case, the universe did the shaking for us, and what we see is the globular clusters getting shaken out and strewn out to help us trace the dark matter and the gravity from the luminous matter in this system. This is going to lead to a never before understood mapping of dark matter in this system. The best is yet to come, but here we see our trace particles. So moving out across our distant galaxy, we have another extragalactic astronomy story. In this case, we have research that was co-led by Jason Dexter and Eckhard Strum of the Max Planck Institute. They were studying Quasar 3C273. That is a rather bland and boring name that identifies this system as a radio-loud source of light. It was first observed optically back in the 1960s and 70s. And astronomer Martin Schmidt, in trying to understand what they were looking at, realized that this object is not a star, even though it might look like one. It is actually a distant quasar, a quasi-stellar object. In this case, further observations over the decades since have allowed us to slowly make out that deep in the heart of all that bright starlight, there's actually a spiral galaxy. And in the core of that spiral galaxy is a solar system-sized region where a black hole is centered and gas and dust spin actively around it. This is an active galactic nuclei. Now, this particular system is 2.5 billion light years away. And trying to observe that solar system-sized region in the center is more than a bit of a challenge. but it's something that is now possible thanks to the combined light of the 4 telescopes in the Very Large Telescope suite. This observatory down at Paranal in Chile has 4 many-meter telescopes, 8-meter telescopes. And by combining their light together through a series of relays using a technique called interferometry, these 4 telescopes can together work like a 130-meter telescope, giving us unprecedented resolution that, were the moon not so bright, would allow us to see a Euro sitting on the surface of the moon. Using this amazing system, astronomers were able to focus in on material orbiting in that inner region of this quasar. And by looking at the individual motions, they were able to make this graph that may not make a lot of sense, but in reality, by fitting a line so that you get blue to the right and red to the left, they were able to divide out the parts of this inner core that were moving toward in the blue and away in the red. Our telescopes, our observing position. And the line that they put through that marks out the tilt of this quasar, allowing us to see how the system is oriented off in the distance. And by measuring the velocities, we're able to confirm once again that yes, the only physical explanation for what we're seeing appears to be a supermassive black hole. Now, coming closer to home, I have a lead-in to a story that's really going to occur on Monday, and this is one that we are particularly proud of here at CosmoQuest. And this is the approach of the Osiris-Rex spacecraft to the asteroid Bennu. Now, this little squarish-shaped object may feel familiar to you. It turns out Bennu and Ryugu, which is the object being observed by Hayabusa 2, are remarkably similar looking rocks. These couple of kilometer across systems are nearby asteroids. Japan sent Hayabusa 2 to Ryugu. It arrived over the summer. And now we have Osiris-Rex, our NASA spacecraft, is going to make its rendezvous with Bennu on Monday. This is going to occur at approximately noon Eastern. I'm always kind of mystified at how they manage to get these things to happen at the top of the hour. That is some mighty fine orbital dynamics going on out there, engineering teams. So Monday at about noon Eastern, we're going to have a live event showing us this encounter. The event itself will start 15 minutes earlier at 11:45 Eastern. That is 4:45 in London and 8:45 on the Pacific. We will be co-streaming everything live for you here at CosmoQuest. One of the reasons this is so exciting to us is we're actually part of the Osiris-Rex team. It is our citizen science software that is being modified and used to help identify the location of that rock on Bennu that they're hopefully going to bring home to the planet Earth. We're just part of a massive collaboration of many different people approaching the same problem in different ways. But we're really proud to be part of this. There's going to be a brief window of opportunity where we hope to invite all of you to join us in that search for that rock that we're going to someday get to bring home. Now, what we're looking for is going to be a region that doesn't have too many hazards, isn't scattered too richly with debris, but has those things that we are able to scoop up. Now, we're going to hear more on Monday. We're going to get a better view on Monday. So I'm going to ask all of you to come back on Monday. If you haven't already, give our show a follow. Get notified every time we go live. We have a variety of different material that we bring to you here on CosmoQuest X on Twitch, and that we then record up on YouTube. So those of you watching on YouTube, press that subscribe button. Give us a follow on YouTube. But no, you're always welcome to click on over to Twitch and watch us when we go out live at 1 p.m. Eastern, 6 p.m. London, 10 a.m. Pacific time. So I am now going to take your questions for the live audience on Twitch. And hey, all of you on Twitch, give us a follow. It's free. Okay, so here we go. If you can please at me in the chat, it will help me identify your questions faster. Let me look and see. Oh, I'm not seeing any questions yet. Wait, here we go. Astro YYZ says, oh, wish you could watch, but you don't have a choice other than 720p. I'm so sorry, Astro YYZ. We need to hit 75 average viewers per stream to make partner. At that point, our viewers will have the ability to pick their bandwidth. But until we get there, I'm sorry, we're just kind of stuck with whatever the Twitch followers, the Twitch servers decide to send out to us. Monday is a very spacey day with the Soyuz launch as well. Sometimes things just seem to cluster up. So disillusioned, yes, the jumping asteroid probe from Japan, that was deployed. They had a pair of really neatly designed landers coming off of Hayabusa 2. They were quite small, just centimeters in size, and were spring activated so that they could hop in 15-minute directed jumps across the surface of Ryugu. The two asteroids are quite similar. We didn't know that ahead of time, but it turns out they're actually kind of hard to differentiate if you look at an image quickly. What's going to be interesting is to see if the science results are similar or different for these two different worlds. They are both near-Earth asteroids, and that means that there's a good chance they could have formed in a similar part of the solar nebula. Now, since asteroids do tend to get rearranged in our solar system, they weren't necessarily formed there, but there's a chance that they were formed at the same distance. So we're just going to have to see. Okay, so Fenring is asking about the quasar. Are the poles oriented roughly toward us, or are we seeing it more on its side then? It's actually somewhat on its side. So let me go back to the graph that I had a moment ago. So if you look in this image, you can see a black line going across the diagonal of this graph. That is the polar axis of the jet. It's located at 220 degrees rotation in the sky. So the disk of the galaxy itself is then going to be perpendicular to this system. So if it were edge on, we wouldn't see this, if it were jet on, we wouldn't see this same sharp red versus blue distribution in the motions. We see that because, I'm looking for something disc-shaped on my desk. So when the galaxy is located like this, as it appears to be, we have a jet coming out here, a jet coming out here. We see we see the objects as they go around like this. They appear to come toward the observer, and they appear to come away from the observer. So this is lined up. Let me do this with a pen and an object. So here's the jet. Here is the disk of the galaxy. So the pen is the orientation of the jet, and this is roughly how the galaxy is going to be oriented. So with this combined disk of the galaxy and jet, you can see where one side you're going to have the stuff moving away from you, the other you're going to have it moving towards you. Now, if instead we're looking at a system that's like this, with the jet pointed directly at the observer, you're not going to have things in the disk that are moving towards you and away from you. You're just going to see a random distribution of slight variations in velocity off of the rate at which the galaxy itself is moving away from us. So the fact that we see some of these are blue shifted, some of these are red shifted, really helps us sort out the orientation of this system. I hope that that answered it instead of muddied it. There are a few jets out there pointed vaguely toward us. We call these BL-LAC objects. They're all sufficiently far away that we don't need to worry about anything bad. So Crispy Fried Man asked, will we one day need a new arrangement of dishes to communicate with the Voyagers? I don't know if a new arrangement is needed so much as we will need added sensitivity over time. As the Voyager missions get further and further away, they still are capable of phoning home. And as long as they remain capable of phoning home, so far, Congress has been willing to allow us to keep paying the money to listen in. We're just going to have to see. Well, we think our technology will keep up and we'll be able to keep listening, which is kind of awesome to think about. Okay, let's see. CubeSats as repeaters. I don't know about that. We're using some pretty big dishes here on Earth when we listen in for Voyager. So it all depends on how technology advances, how sensitivities in our detectors increase over time. But at the end of the day, you can only collect so many photons of light with a small dish. Bigger dishes allow us to hear things that are fainter by gathering up more of the light that they're emitting. Oh. All right, I love the engineering sides of what you're suggesting, Larry. Larry's suggesting that, and let me go back over to the view so that everyone can see the questions. Larry is suggesting that we should have a set of kilometer-sized dishes. I'm assuming you mean in Mars' orbit around the sun, not orbiting Mars itself. That would get awful busy in orbit. I'm hoping that we'll find other ways to confirm the Oort cloud before we have to resort to such significant interplanetary construction of dishes. So do we have any other questions out there? While you type those in, I'm going to remind you that we are produced by you, not your actions. We take care of the day-to-day work of getting the productions out the door, but we're able to do things like pay salary of our staff to make sure that everything gets edited and put up and keep the lights on, thanks to your contributions. Every bit really matters, especially right now. We have long been funded by NASA, but we were warned a couple months ago that due to cost overruns from the James Webb Space Telescope and changes to policy within NASA, there was a chance that we might get a cut to our funding, and we got a significant cut to our funding. We found out about this at the very end of October and have been scrambling to figure out how do we not fire all of our staff, including me, for Christmas. Right now, we're in the process of doing a massive fundraising effort that will allow us to keep things going until we can find that next grant that will be your tax dollars at work. So until that can happen, can you help and give a tax-deductible donation where tax law allows and help us out? We are taking donations through Streamlabs, and as always, bits are fabulous. I see Paranor has given. Thank you so much, Paranor. Can we light up that chat? So yeah, we are going to be doing a massive fundraising effort in the next month that will culminate in a 40-hour stream on the weekend of December 22nd, 23rd, and going in to the first hours of December 24th for some parts of the planet Earth. So here is to making Christmas bright and filled with science. Yes, all of the ways that you can help are listed below this video. Please check this out. So onward and upward, I am here to answer your questions for a few more moments. Thank you, Lancey, for the bits. And yes, Hired Gam, 40 hours. We don't do things small. The universe is large and it deserves our undivided attention. And we're going to give it 40 hours of our attention. Thank you so much. Oh, I'm trying to make out your name on a light background. Thank you so much, Jack Skodens. We really, really appreciate that. Thank you. Thank you, dear Strat. Thank you, Desert Rat. Sorry, I totally misparsed your name, and I know what your name is. Thank you so much, Desert Rat. Thanks all of you for your support. We're just here to invite you to help us explore our universe, to help us map out other worlds and discover the safe place to put a spaceship and the interesting places to explore. And we're going to work our butts off to do the best we can by you, to educate you, to make us our peers, our colleagues, to bring you the daily space on a nearly daily basis, Monday through Friday. And we're just glad to have you here. So thank you so much. And I'm not seeing any more questions. So I'm going to tell you some of the things that you can get involved in over at CosmoQuest.org. We have a variety of different citizen science projects. One of the best ways you can get involved right now is to help us map out Mars and Mercury. We're trying to understand the crater distribution on these two very different worlds so that we can answer questions about how old is the surface in different places? How much secondary damage does Mercury get when it gets hit by an asteroid that might fling bedrock up that will come crashing down further away, basically causing Mercury to crater itself? All these kinds of things are things that you can get involved in. So Susie is asking if there's any insight updates today. I haven't seen anything yet, but there might have been some updates in the past hour and a half that I missed. They are coming out of the West Coast, so later in the day is when I always expect to hear things from them. So Fenring is saying, so back to that quasar again. Is the line in visual image the actual jet coming out of the poles? I don't think so, but I could be wrong, and I wasn't able to figure that out fast enough today. So here is the image that he's referring to. You can see that there is this thing here. Now, I don't know where in space that is actually located. It could also be something in the image, although that appears to be something actual in space. In general, jets are visible in radio light and not in optical light. So I'm just not sure what that structure is. So I can't answer your question. I'm sorry. I need to go find out more about that image other than what I was able to find out. So I did not follow the ISRO launch. Annie did that. We're a team around here. So check in with Annie this Sunday when she comes on for Sunday Science Time. She'll be doing office hours and astronomical art and visualizations right here on our channel. It is not Cosmic Strings, Fenring. Okay. So yes, so many different things going on around here. And it does take, well, it takes a village to raise a child, and it takes an entire world to raise up our understanding of the universe. And we're really happy to get to work in a collaboration of people who kind of enjoy getting to work together. And Annie covered us yesterday, and you can go check out her coverage over on our YouTube channel. If someone can drop a link into chat with the YouTube channel, that would be great. Again, if you can consider just following or subscribing to that YouTube channel, because subscriptions on YouTube are free, we'd really appreciate it. Yes, Larry, some jets are capable of generating stars. The shock waves of these literal jets of material streaming out of the centers of galaxies, pushed by magnetic fields, they are capable of shocking material into forming stars. Hey, Veronica, welcome. I'm glad to hear that Annie did a good job on the launch. I wasn't able to catch that. So if there's no more questions, I'm going to thank you all for coming. I will be back here tomorrow at the same bat time on the same bat channel, bringing you more of what's new in space and astronomy. This has been the Daily Space. I am Dr. Pamela Gay, and I'm just happy that all of you were here and let me put science in your brain. We will return, as I said, tomorrow. Tomorrow's episode will be at 1 p.m. Eastern. That's 10 a.m. Pacific, 6 p.m. London time. If you miss any episodes, catch them over on YouTube. I can't tell you what we're talking about tomorrow because the news has yet to be announced and the science, in some cases, has yet to be written. So thank you all for being here, and I'll see you tomorrow.